Very simply, this video lesson is on how to solve the problems from Solution Theory Part 1. If 2.50 grams of calcium chloride are dissolved in 250 milliliters of water, and question number 1 or A here is, what is the molar concentration? And we're going to assume that the volume of the solvent is equal to the volume of the solution. And a funny thing happens when you're dissolving salts in water or ionic compounds in water. Very often the volume doesn't change much at all. Okay, so this is not an unusual case that it would happen like this. But what we're going to do is to find the molar concentration first. And molar concentration, capital M, we usually draw a line under it when we're doing that, is moles of solute over liters of solution. There are a lot of ways to do the math, but basically you've got to find the moles, you've got to find the liters, and divide to get molar concentration, or the molarity of the solution. Let's see. One way we can do this is to start by finding the moles. Now the problem states that we have 2.50 grams of the solute, and we want to find moles of that. So we've got to calculate the molar mass of calcium chloride. Calcium's atomic mass is 40.08 on the references we use in this class anyway, times 1 because there's only 1 in the formula. Chlorine's atomic mass on the periodic table we use in this class is 35.45, and there are 2 of them in the formula. And we're going to add those together. The sum of the atomic masses of all the atoms in the formula in units of grams is the molar mass. This is 110.98 grams of calcium chloride. I'm sorry, you're right, there should be a 90 here. So that's equal to 1 mole of calcium chloride. Okay, so that is a 9, you're right. I'm not sure why I wrote 7 again, but it's a 9. Okay, so that's the molar mass, and when you write it this way, and this is the way it's required in my class, then you have everything you need to write a conversion unit, because you've got 2 things that are equal to each other. When we put it in a fraction, we get a fraction that equals 1, which is going to change the way we measure the starting amount, but not actually change the amount of it. We're going to put 110.98 grams on the bottom. We put that on the bottom so we can cancel grams and the species in this case. And we're going to put the 1 mole on the top. Cancel grams, just like x's and y's in algebra. Cancel calcium chloride, just like x's and y's in algebra. And we can do the math. So this is the number of moles of calcium chloride before we round off. Looking at the measured and calculated numbers in the problem, there are 3 digits in this measured number here and 5 digits here. We want to match the least number of digits of the measured and calculated numbers in the problem with our final answer. Leading zeros are not significant. 1, 2, 3 significant digits, underline everything else. Draw an arrow to show that we are actually rounding off. And we get 0.0225 moles of calcium chloride. Okay, so that's the top part of the molar concentration. Now we've got to look at the bottom part. The problem states that we have 250 milliliters of water. Which we said is going to be the same volume as the volume of solution, so we're going to call this not the water but the calcium chloride solution. Put that over 1. Got to convert it into liters because we need liters of solution on the bottom. And we're going to write out that there are 1,000 milliliters in 1 liter. And we can build a conversion unit from that to things that are equal. 1,000 milliliters, 1 liter. Cancel these units here. And we get 0.2500 liters of calcium chloride solution. So that's what's going to go on the bottom here. Okay, so we're just going to put it together now. Moles of solute over liters of solution. So we take 0.0225 moles of calcium chloride and put it over 0.2500 liters of calcium chloride solution. And I get exactly 0.09. So what you guys got? Did anybody get that? Can anybody hear me? Did you do the math and what answer did you get? Alright. That's what's on the calculator. But I need 3 digits because this number has the least number of digits, so I need to put 2 zeros here. Oh, that's moles of calcium chloride over liters of calcium chloride solution. But that is 0.0900 molar calcium chloride solution. Okay, that's the same thing, because moles of the solute over liters of the solution is molarity or molar concentration. Okay. Now this is not the only way to do this problem. You can also do this problem like this. It's one sort of long problem here. Okay, where we put in this problem, I did this calculation here first to find the moles, and a separate calculation to find the liters, and then put it together. Up here, I took the moles, I took the grams and found the moles, divided by the volume, and then converted to liters. So I got the same, basically the same answer, slightly more different because of the way we're rounding off. So the second part of the problem is, what is the mole concentration? M-O-L-A-L concentration. Mole concentration, which we symbolize with a small letter m, is the moles of solute over kilograms of solvent. Not the solution, but the solvent. So in the problem we have 2.50 grams of calcium chloride. We've got to convert that into moles. Well, if you did that in step 1, there's not much reason to do it again. We've already got it done. Okay? What we have to do is to find the kilograms of solvent. We're given the amount of solvent as 250 milliliters. And you need to remember the density of water is 1 gram per milliliter. At least it can be rounded off to that. So we'll take that 250 milliliters of water, put it over 1, and we'll use the density of water, which is 1.00 grams per milliliter, and we're going to write a conversion unit from that. So milliliters we're going to put on the top. 1 milliliter of water is equal to 1.00 grams of water. Oh yeah, I do. I don't know why I switched them around like that. You're right. Let's fix that. I'm not sure why I did that. Yeah. You think? Just trying to be nice? Okay. And actually, this is an absolute number almost. I mean, we could assume it to be an absolute number, so we should say grams on the top, milliliters on the bottom. Milliliters are going to cancel, water's going to cancel, and we're going to have 250.0 grams of water. Okay, well that's not enough because we've got to have it in kilograms. So we take that 250.0 grams of water, put it over 1, and we need the conversion unit to go to kilograms. Well, you need to know there are 1,000 grams in 1 kilogram. So we're going to put 1,000 grams on the bottom and 1 kilogram on the top. Cancel out grams. And we get 0.2500 kilograms of water. Why did I have that many significant digits? Your calculator is only going to show 0.25. That's because there are 4 significant digits here, and this is an absolute ratio. When you're converting from 1 kilo to a base unit or from a milli to a base unit, those ratios are absolutes. Okay, they are defined. They're defined values, defined ratios. And so if they're defined ratios, we don't consider those. Those can be considered infinitely significant. Okay, so we go straight with whatever the only measured or calculated number is in the problem, and that's this one. All right, so now we're ready to put it together. Our molar, our number of moles in this solution is the same as this. So we're going to take that 0.0225 moles of calcium chloride, and we're going to put over the amount of water, 0.2500 kilograms of water. And we're going to get the same answer as we did on the previous one, but with a different unit of measurement. Now, it doesn't always work out that way. It just happens to work out that way kind of nice this time. 0.0900 moles of calcium chloride per kilogram of water. And we know that moles of the solute over kilograms of the solvent is mole concentration. So we can say that's molar calcium chloride solution. Now if the solvent is water, you can simply say, you can name the solution by the solute. Okay? Because water is used so much, it's used almost all the time in high school chemistry, that we can say it's ubiquitous. Okay? So that if you don't name what the solvent is, it's assumed to be water. And if it's not water, you better name it. That makes sense? But if you don't name it, then it's a reasonable assumption. It is an expected assumption. It is an implication that water is the solvent. A percent concentration is always mass of the solute over the mass of the solution. The mass of the solution is both the solute and the solvent. Okay. So the mass of the solute in the problem is 2.50 grams of calcium chloride. The thing that gets dissolved is the solute. And then the mass of the water we have to figure out. But in the previous problem, I think we figured it out, didn't we? We figured out the mass of the water is 250 grams because we used density to get there. So we basically have everything we need to start this problem then. The mass of the solute is 2.50 grams. That's calcium chloride. The mass of the solute, 2.50 grams of calcium chloride, plus the mass of the solvent. And in the last problem, we figured out the mass of the solvent was 250 grams. We have to match the units here. In order to cancel out units that you should cancel out in a percent calculation, you should always have matching units. You have to have matching units to make all this work out. It doesn't make sense otherwise. So 250.0 grams of water, and then the whole thing gets multiplied by 100 to get the percent. So that's 250, or 2.50 rather, grams of calcium chloride divided by this all added together. So that comes out to be 252.5 grams of calcium chloride solution. Now to be safe, let's show how we got that so we can show how we add numbers together and round off properly. 2.50 grams of calcium chloride, 250.0 grams of H2O. I'm going to add these together. We get 0.5252, but there's an empty slot here. And whenever there's an empty slot, when you're adding or subtracting, the resulting digit here is insignificant, so we've got to round that off. So this is grams of calcium chloride solution. So round it off to 252.5 grams of calcium chloride solution. And that's where we got that number from. And then that gets divided and multiplied by 100. Going to round it off to the correct number of significant digits. There are 3 significant digits here, 1, 2, 3. Round off everything else. Remember that whenever you're doing percentage calculations, the units of measurement should cancel, or otherwise it doesn't make any sense. Okay? So make sure you show that. Going to round that off, and we get 0.990% calcium chloride solution. Again, if the solvent is water, you don't have to name it. If the solvent is not water, you have to name it.